welcome back to my bench. Today we have one of my pieces of test equipment. This is a Sencore DVM38, and it has always been one of my favorite meters. I don't really know why. I guess probably because it's almost as old as I am. But other than that, it has a couple of things that are nice about it. If we look here, it'll go up to 20 meg ohm input, which is nice. And it's you don't use it very often, but it's helpful. It'll do 1 kilovolt maximum, which I'm not sure is how I would do that, but anyway. It has auto ranging on these 220 and 200 and 2000 volt scale, or well. But one of the other things it has is in ohms it has low power, which is nice because it won't turn on diodes and things. And other than that, it only has 2 inputs over here. So you want to measure current, you don't have to move anything. Well, that can be good or bad because it's pretty easy to blow the thing up if you're not watching what you're doing. It also has a 20 ohm scale, which will take you down, let's see, there, 20 ohm scale on low power. That'll take you down quite a ways on even the new measurements and things that we have these days. So I like it. So what had happened was I bought one of these things and off of eBay, and it was terrible. It did not work worth a hoot. I mean, at all. And I found out why, and I'll show you here in a minute. So, and then I went out and bought another one that I got cheap because the guy says it didn't work right, but at least it showed something on the screen, and I said, okay, we'll give this a shot. So I think I got maybe 30 bucks in the whole set, 2 of them, and neither one of them worked right. Well, the first one, it was virtually dead. It lit up a little bit, but everything was wrong, and I said, okay, that's never mind. But then I had it on the bench, and I said, you know what, I'm going to buy another one. So I did, and that one actually lit up, like I said, but it wasn't right exactly, and a lot of parts were bad on the inside. So what I did was I took 2 of them and made the best I could, and it worked. The problem with it, the original one, was this IC right here. That one. And the problem with that one was it was blowed up. And that is the A to D, A to D converter. And trust me, you don't buy those unless you get one that for parts. So I bought the other one, and the A to D converter was good. Everything else was kind of bad. The switches were destroyed. Half the knobs were missing. The LEDs didn't work right. Some of them came on, some of them didn't. And basically, it was a mess. So, like I said, I took 2 of them, put them together, made one. And this is what I ended up with. Well, this one works okay now. The only problem with it is when you turn it on, I'll show you here. We go to DC volts. If you can see, right here is the little light that tells you whether it's plus or minus voltage. That stays on continuously, just all the time. It doesn't change, and that gets a little bit irritating because you don't know what polarity of voltage you're looking at. So I said, you know what, I'm going to sit down and fix this. So here we are. Well, I got a manual, downloaded a manual for it. I'll pull you out a little more, and went through it, and it doesn't have an actual full honest to goodness schematic in here, but it's got schematics of each individual little piece, which is interesting for a manual, but I started looking around, and since everything else worked, I wasn't too worried about it. And in here, I found a basic function diagram. And the function diagram says the inputs all go into the analog to digital converter, which I knew. Digital output goes over to the display drivers, and the display drivers drive the display. And then there's an output that goes to the polarity right there. Let's get in here a little bit. Like I said, it goes into the analog input, and then digital drivers, the anode goes out to the display, the digital drivers go over to the display, and then there's a polarity that comes out of one pin and goes up to one of the displays. So I said, okay, that looks like a good place to start. So I did. And if I go through here, it's got AC current, shunts, AC voltage converter, how the resistance works. It's rather complicated. It's not just a resistance measurement device. It has a timing and all that kind of stuff. And auto ranging. And then I got over here to the last page. And right here, it says that out of that IC207, which is that thing you can't find anymore, it goes into, through this resistor, through this PNP transistor, and onto pin 7 of the LED that shows plus and minus. And it describes, it says the polarity indicator circuit lights the plus LED indicator in the DC voltage and current functions according to the polarity of the input signal. In the DC function, on that switch, switch 101, connects the polarity indicator diode at pin 1 of D301, which is that guide, to the display mode. The ground return for the minus display segment is made through R301, which is right there. So this indicator is on continuously. So the negative side is always on, and so the positive side is always on, of course. And when the measured ramp voltage of IC207 is positive going, a low output occurs at pin 8, which turns TR206 on. This completes the ground side for the plus indicator side of the display. So the negative side stays on constantly. The plus indicator supply is what we're switching. And basically, we're going to find out what it does. See what's wrong. Something's wrong in there, and we'll find out what it is. And in order to do that, I am going to take my handy-dandy power supply over here with the 5-volt. Never thought I'd ever use this 5-volt standard standby, but here we go. We'll plug this in normal, and we'll hook it up plus to plus, negative to negative. Make sure we're on voltage. We are. There we go. And we got 5 volts right there. Whoops. There we go. Alright, now we're going to switch them around. No volts. Put the plus in the minus and the minus in the plus. It switched, and we're still at plus 5 volts. That's my problem. It's not changing. So what we're going to do is we're going to measure some stuff in here. Okay. Yep. Okay, we got 5 volts. We're on negative. All right. So we'll take another meter here, and we'll put it on plus voltage. We'll ground it. Ground is ground in this. And this is that TR206 right there. That's the one we're going to be looking at. So, and they're marked. Oh, that's nice of them. Okay, so first of all, the base comes out of this pin. Oops, where is it? Right there. Goes into the base, and this should be high at this point. No, let's see. Yes, I think the base. Oh, I don't have anything hooked up. In regular mode, it is nothing. There we go. All right. In regular mode, it's low. So it's a PNP. If it's low, it's turning on the transistor is going to ground, and the plus is lit. And it is. So let's switch it around. Let's see if I can. Alright, there's the meter right there. Alright, so here I am. If I go to base, base is 0.165 volts. It's low, so the transistor's turned on. Alright, let's switch the needles around. And now we'll go to the base. And it is now high, which means the transistor is off, but the positive negative is, you can't really see it through here, but it's still on and lit hard. Okay, well, interesting. Let's we got to figure out. So coming out of the IC is good. All right, now we got to figure out what's wrong with the IC, with that transistor or something. So let's disconnect it. Turn it off. All right, and put the meter on that. So I don't know if you can hear that. I hope so. So there's the base, there's the emitter, 0.67, base emitter, base collector, 0.675, turn them around, 1.6 volts, whatever. And base collector, same, 1.63. That's exactly the same. All right, now we go emitter collector. Aha. So looks like I got emitter collector short on that transistor. Cool. Well, let's take it out and find out. Yeah, where is it? Looks like it's right there, I believe. All right. Had to find the solder wick. Oh boy, I got a new chair in my shop, and I discovered, since it has nice wheels, that the whole shop slants downhill, and every time I get in, I roll downhill. And the chair's not high enough. I gotta do something about this. Alright, so I'm gonna solder wick this out instead of try it. We are off completely. Add a little solder. Add a little bit of flux. Probably should get the fan out to suck away this flux, but meh. Wow. Wrong soldering iron for this, but it's the one I had heated up. Come on. Man, there's a lot of solder there. Doesn't look like it. It certainly is. Alright. Ow. Whew. Trying to grab a hold of it from the other side without burning myself, if at all possible. Which it isn't. Alright. Youch! Okay, so we got that out of there. Now, let's see if we can get that as I go rolling away again. Yeah, you may have noticed too that I'm at work and I got a mat. Nice. Hopefully keep me from shorting stuff out on that nasty carpet that's been there since 1984. That was a mistake. Putting carpet on a bench. Just don't do it. May look good, but it ain't right. Okay, there we go. So let's see what we got. Well, we can just measure this. So this thing you actually marked? No. What is it? It's a 3906. So let's see, EBC. Alright, so emitter base. There we go, base collector. No, emitter collector short. Alright, well, that answers that. We have a shorted transistor. Now I gotta find one. Well, I'll be back for that. Hold on. Okay, I went searching through everything I had, and I came up with an ECG. That 129. Well, that's a big honker. So let's let's test it and see what it is here. Should be PNP audio transistor capable of 5 volts, which is all it has to be capable of. And push the button on the magic box. It is a PNP, and it is 1, 2, 3 emitter collector base. Okay, so 1, 2, and 3. So 1 and 3. This is 1 and 3. So emitter. Okay, so it's over there. Yeah. Collector to case. So that's the collector. That's the problem with the way I've got this thing set up. It's I can't tell what's what on that thing. It's not made for that. So it says, it doesn't say. That's cute. Let's test it. Okay, so it goes emitter base collector. Okay. So emitter base collector, so it would go in there directly like it is. Cool. Yep, a little tab points to emitter, if I remember correctly. It's been a while since I've dealt with any of these type of can guys. I know it's silicon. It is 0.6 of a volt, so it has to be. Wow, come on. Straighten your little legs out so you'll go in there. Okay, that's in there. Yeah, I know the metal can't be touching. Well, no, collector's ground, so it wouldn't make any difference. All right. Sits right down on there like it was made for it. It actually might have been made for it at one point or another. Who knows? I don't know what all's been done to this. I know I did not change this part, so solder it back in. Take a look at it. How's it look? Get that a little bit more better there. There we go. Wrong soldering iron for the job. You would think I would know better, wouldn't you? Okay, and trim off the leads. There we go. Now, let us see. Let's see if I can poke this up there so you can see it too. All right. Put everything else away. And what did I do with leads? Here they are. They're still hooked up. We'll go standard here. Turn it on, plus, well, it looks better already, okay? So let's swap it around. Ta-da! We got it. All right, plus and minus shows up like it should. There you go, quick fix. And just to show you how we did a little tracing. So plus voltage and minus voltage. All right, and they're both the same too, I think. 5.09, 5.07. Yeah, 100th of a volt off. I'm happy. So I already did alignment on this thing. I'm not going to do it again. It's not easy. It's a pain in the neck. So anyway, hey, we got it. Thanks for watching, and don't forget to subscribe and hit that little bell if you want to know when I do another repair. Till next time.